I've already shown this in some of the other example problem videos, but I want to be explicit that molecules with more than one central atom have molecular geometries around all molecular and electron geometries around all atoms that are bonded to more than one other atom. Okay, so make sure that when I ask a question like, what is the geometry around the atoms in this molecule? You don't just pick one atom and leave the rest out. So consider, for instance, this vinyl alcohol. The Lewis structure is shown up here for this atom. Notice there are 1, 2, 3 central molecules in this atom. Central atoms in this molecule. So if we consider each of these particular molecules, we look at, say, oxygen for the first one. If we think about the electron geometry around it, there are 1, 2, 3, 4 bonding domains, electron domains, and so it's a tetrahedral for the electron geometry. For the molecular geometry, we have 2 bonding domains, this one and this one, and 2 non-bonding domains. If we look at our table, or just think about the shape that is, remember these two would be coming out the same side of the molecule, and that would cause these to essentially squish down and become bent, and so that's where we get this bent from. If we predict the angles around these, all the angles will be approximately 109.5 degrees. Okay, so if we go to the second carbon here, or the second atom, carbon, we see that it has 3 electron domains, so it's a trigonal planar electron geometry. Go to the molecular geometry, notice that all of the electron geometries are in bonding domains. Okay, this is bonded to the hydrogen, this is bonded to the oxygen, this is bonded to the carbon, and so it should have the same electron and molecular geometries. And the predicted angle would be 120. We go to this last one, it looks a lot like the other carbon. It's got 3 electron domains, all of them are involved in bonding, and so they all have the trigonal planar. Now let's go ahead and try an example problem with multiple central atoms. So it's got multiple central atoms, and it also has, we haven't actually done an example problem where we've talked about molecular geometry. So let's determine molecular geometry, electron domain geometry, and well, those two things for this multiple central atom molecule. Okay, so first off, I got to draw a Lewis structure. That's the first step in all of these problems. So let's get out the handy dandy pen, start doing valence electrons for this. Well, we have 1, 2, 3 carbon. So carbon has 4 valence electrons. There are 3 of them, so we put a 3 here. We have 4 hydrogens. Hydrogen each have 1 valence electron, and then we have 1 oxygen, right? It's just 1. Okay, 1 oxygen. There are 6 valence electrons there. 6 times 1, so we have 6. We have 4, and then we have 12. So that's 22. We should have 22 electrons in our Lewis structure. Now we start drawing the Lewis structure here. Remember, the rule is that carbon will always have 4 bonds and oxygen almost always has 2 bonds, okay? So looking at here, we see that carbon's bonded to 3 hydrogens, which is bonded to another carbon, which looks like it's bonded to an oxygen and another carbon. So the oxygen goes like this, the carbon goes like that. In order for carbon or oxygen or this carbon to have 4 bonds to it, we need to put either a double bond here or here. Well, with oxygen being off like this and the other hydrogens looking like they attach to this carbon, that tells us where the double bond goes. So the so the hydrogens come off like here, here, and here for this other one. Now notice you could have put an oxygen right here and bonded that oxygen to a carbon which is bonded to 3 hydrogens, but if you did that, you could not, if you put a oxygen right here, you'd have to have 2 bonds to this carbon in order for the carbon to have 4 bonds total, and that would be a less good Lewis structure. It would have higher formal charges on many of the atoms. So this is the best Lewis structure for this molecule. Let's determine the molecular geometry, MO, for central atom 1, 2, and 3. Oh, 2 and 3. And electron, or I should say molecular geometry, so it'd be Mg and Eg. So molecular geometry for that first one should be, or let's do Eg first. Electron geometry for carbon 1 would be tetrahedral, because it has four electron domains. They're also all involved in bonding, so it'd be tetrahedral for the molecular geometry. Tetrahedral. We move to the second central atom here. We see that it's got 3 electron domains. All of them are involved in bonding, so it'll have the same electron and molecular geometry. So this one is called trigonal planar. And trigonal planar. This is for 1, 2, and then if we look at the third one, we see that it's got 4 electron domains. They're all involved in bonding, and so that would also be tetrahedral, tetrahedral. I'm not going to write it because I'll run out of room over on this side of the screen, but that's what they would be.